In this video, I'm going to review the problems from example 2, in which you were asked to convert a base 10 numeral into a base that was smaller than base 10, and I'm going to be using the method that the textbook recommends doing it.
So using the traditional method of doing this, and this what I'm showing is a version of it. It's not exactly the way it looks out of the textbook, but it basically is the same thing. I'm going to convert here 77 into a number that's base 4 that's equivalent to it. So the first thing I'm going to have to do is look at my powers of 4 and see which powers of 4 would be involved. I mean, any power of 4 that's bigger than 77 would obviously not be involved, and any power of 44 that's under 77 could potentially be involved to a certain degree, because they should be, possible factors or what have you. So looking at some powers of 4, I have 4 to the 0 being 1, 4 to the 1 being 4, 4 squared being 16, 4 cubed being 64, getting bigger, but still should be able to potentially, divide into 77, even if maybe it has a remainder. 4 to the 4th power would be 256, which is too big. 256 cannot in any way divide into 77, giving me a whole number, a part of the quotient, and then a remainder. So 4 to the 4th power is out here. So these are the potential powers of 4 that could be involved with this. So now I'm going to look and see, okay, well, how many 64s can go into 77? Well, two 64s would be 128, so that'd be too much. So basically, I could get one of these, or carry through the division. I get one of these, and I get 13 as a remainder. So the 1 would go here. This 13 is what's left over after I subtract the 64 from the 77. So I have 13 left to go into becoming a number base 4. This number 13 is less than this 16. So there's not going to be any power of 4 squared being involved in this number, because I would produce a number that's already more than what I have left. So I put a 0 there, and I'm going to move that 13 over. So look at now I'm in the 4's position. How many 4's would go into 13? Well, I would carry through the division, and I would have 3 of them and a remainder of 1. So I would get a 3 here. And the remainder at this point, once I get to the 4's position and do my division, it's going to be a remainder. That's just going to go in the 1's position. And so the number 77 written in base 4 is 1031. Let's try 855 base 6. So again, I'm going to consider powers of 6. So I have 6 to the 0 power, which is 6, 6 to the 1, which is 6 to the 0 power, which is 1, 6 to the 1 equals 6, 6 squared is 36, 6 cubed is 216, 6 to the 4th is 1296. That's too big, so I'm not going to include any of those. So now I want to see, okay, well, how many 6 cubes go into 855? So I would take 855 divided by 216. I would get 3 with a remainder of 207. So the 3 would come here. I would take this 207, and now I'm going to divide it by the second power, 36, and see how many of those I could pull out of what's left over. So 5 times 36 is 180. I get a remainder of 27. So I have 5 in this position. This 27 is what's left over after I subtract away these 5 36s. And so now I'm going to move that over here and divide it by 6. And I do that, I get 4 with a remainder of 3. And so the 4 is going to end up here. The 3 is going to end up over here at this point, because there's nothing more to divide at this point. There's no other lower power of 6. So at this point, the number is 3543. Now, 1284 base 2. So basically, I'm going to be writing this in binary format. Quite a big number, because powers of 2, I mean, they don't get as big as quickly as some of the other bases we looked at. As a matter of fact, the list of bases I had to come up with, I have my 2 to the 0, which of course is 1. 2 to the 1st is 2. I come all the way up here to 10 to the 10th, which is 1024, which is still less than this. If I would go to 2 to the 11th, I would have 2048, which would be over this. So I didn't write the one that I wouldn't include here. But these are all possible factors that will divide into 1284. So I'm going to start with this one here and take 1284 divided by 1024, and I would get 1 as a quotient with a remainder of 260. So the 1 is going to go here. The 260 I'd move over here to divide. But 260 is bigger than this 512. So 512 or 2 to the 9th cannot be a factor of this. I cannot pull any of these from it. So I'm going to put a 0 here. And then I'm going to move this to the next position and say, okay, well, 260, 256, I can pull something. I can pull a 256 from 260. It's smaller. So I would take 260 and divide it by 256. There should be a 256 here. Let's put that in really quick. And when I do that, I get 1 with a remainder of 4. So the 1 I'm going to write in that position. And the 4 I'm going to bring over here to divide again. Now, 4 is less than that 128. So, I'm not going to be able to make this a factor. It's also less than this 64. It's less than this 32. It's less than this 16. It's less than this 8. I don't get a number that's less than or equal to that number, that 4, and so I get to this column here. So all these other columns that I've looked at here, all of these are going to need to become zeros, and I'm going to need to move the 4 over here. So now the 4 is over here, and some of this got a little wonky here. So now I'm at this page here that I can divide a 4. So I can divide a 4 by 4. I get a 1, which is going to come up here. I get a remainder of 0, which means that anything to the right is going to have zeros in them. And so the number that goes in this position is, and I extended my line a little bit here, 101. 0, 0, 0, 0, 0, 1, 0, 0. So binary numbers can get quite lengthy just for, once you get to values in base 10 that aren't considered to be huge. So be on the lookout for that at times, is that you're going to have some lengthy numbers when you get numbers that are higher in quantity if you're converting to base 2. 642 to a number in base 8. So again, I'm going to come up with my powers of 8, and these are the powers of 8 that are going to be less than this 642. 8 to the 4th, offhand, I couldn't tell you what that is, but it was bigger than 642, so I didn't include it in this list. So I start with this number over here. I'm going to take 642 divided by 512. I get 1 with a remainder of 130. So the 1 gets written here. The 130 I'm going to bring over here and divide by 64, which can happen because 64 is smaller. So when I try that, I get 2 with a remainder of 2. So the 2 will come here. I bring a 2 over here to divide with the 8, but that 8 is bigger than 2, so I can't do any division here. So the 0 would be put in this position. The 2 gets moved over to this position. And at this point, it's a remainder. I could go through the process of like multiplying it by 1 and get say, okay, 2 with no remainder, but pretty straightforward. It's 1202. Now the number 12,304 in base 5. So I'm going to list my bases of 5, my powers of 5. I list all those that are up to and including the greatest that's less than or equal to 12,304. So 3125 is the highest power of 5 that I can get that will be a potential factor of this. So I'm going to take 12,304 and divide it by 3125. And I get a 3 with a remainder of 2929. So the 3 comes up here. The 2929 comes over here, and I'm going to divide by 625, which 625 is smaller than this, so I can carry through that division. And when I attempt that, I get a 4 with a remainder of 429. So the 4 gets put here. The 429 remainder comes over here to be divided with 125, which can happen. So 429 divided by 125, I get 3 with a remainder of 54. So the 3 comes here. The 54 comes over here to be divided by 25. Now, 25 is smaller than 54, so that division can happen. So 54 divided by 25 gives me a 2 with a remainder of 4. So the 2 is written here. The remainder of 4 would be brought over here to be divided by 5, but I can't divide it by 5. 5 is bigger than 4. So I'm going to put a 0 here, move this to this position where I would usually divide, but this is the 1's position for this number. So anything that ends up over here would be a remainder anyway, so that's a 4. And so the number that in base 5 that's equal to 12,304 is 343204. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.